Hello friends, this video on Gravitation Part 2 is brought to you by examfear.com. No more fear from exams. Please make sure that you have watched Part 1 before going ahead with Part 2. So, what is universal law of gravitation? And we also saw that a constant, that is gravitational constant, capital G, was introduced. Now here what we will see is, I told you that this G is a universal constant, that is its value remains the same throughout the entire universe. So here we will see how did we determine the value of G. So it was an experiment performed by Cavendish wherein he evaluated the value of G. So we will see in this experiment how did he calculate the value of G. So what Cavendish did was, he took a wooden plank, as you can see in this diagram. He took a thin thread and a wooden plank, and on the wooden plank he attached two small balls. Right, so he made this arrangement and he hung this from a support. There is a support at the top through which he hung this thin thread, and at the bottom he had a wooden plank with two balls on the two sides. Then what he did, he introduced another similar arrangement, but there were two very big balls which were suspended from again certain arrangement. Right, and how he arranged it? He arranged it in such a way that these two big balls were nearby to the small balls. Now what he observed was, these two small balls got attracted towards the bigger balls, and this wooden plank started rotating. It rotated to some extent. As a result of this rotation, this thin thread also started twisting. So this thread started twisting and this rotated. So this started rotating and the thread twisted. Why? It happened because of the force of gravitation between this and this ball, and similarly between this ball and this ball. Right, so this was the experiment which Cavendish performed. So in this experiment he found that the plank rotates. Plank means this wooden plank. The plank rotates till the twisting force, that is the force of this wire being twisted, this twisting force is equal to the gravitational force between the balls. That means till the twisting force is equal to the gravitational force between the balls. Now what is this twisting force? The twisting of the wire was caused by the torque. So till that torque is equal to the gravitational force. What will be the gravitational force? It would be G m1 m2 by r square, where r is the distance between the two balls and m1 and m2 are the masses of the balls. Now what is torque? Torque is nothing but L into theta, which is equal to G m1 m2 by r square. So using this expression he calculated the value of G. So because he knew the masses of the two balls, because he was performing the experiment, so he knew of what mass the balls are. He also knew the distance between the two balls because it was he who arranged the balls near each other, so he knew the distance between them. He also knew the angle through which it got rotated because he measured that angle, and he also knew the angular momentum. So because these all are the quantities which is capable to be measured experimentally in the lab. So he measured all these quantities and he evaluated the value of G. And it was found that the value of G was 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now that we discussed the value of G, which is 6.67 into 10 to the power minus 11 Newton meter square per kg square according to Cavendish experiment. Now we will discuss about the unit of G. How do we get the unit of universal gravitational constant? See, from the mathematical expression, we know that F is equal to G m1 m2 by r square, right? So what is the value of G? G is nothing but F r square divided by m1 m2. Now let us write following quantities in terms of their units. Now what is the unit of force? It is Newton. The unit of R, what is R? R is nothing but the distance between two bodies. So this is meter. So meter square. What is the unit of mass? It is kg. Since mass into mass, so it will be kg square. So that means the unit of G will be Newton meter square per kg square. Therefore, the value of G which we get is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Right, so I hope it is clear that how do we get the units of different quantities. It all depends on the units of the quantities on which this particular quantity depends. So we learned what is universal law of gravitation, mathematical expression of universal law of gravitation, how do we calculate the value of gravitational constant, and the unit of universal gravitational constant. Now let us go ahead and look at some simple problems based on whatever we have studied. So let us see this problem 1. It says calculate the gravitational force of attraction between two lead balls of mass 20 kg and 10 kg separated by a distance of 10 centimeters. So in this case we are given M1 is equal to 20 kg, M2 is equal to 10 kgs. Distance between them, that is R, is equal to 10 centimeters. Let us convert it into meters. So this will be 10 divided by 100, which is equal to 0.1 meters, right? Now we have to calculate the gravitational force. That means we have to calculate the value of F. We already know G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Therefore, applying universal law of gravitation, we say F is equal to G m1 m2 by r square. So we will just put down the values, that is 6.67 into 10 to the power minus 11 into 20 into 10 divided by 0.1 whole square. So this will be equal to 6.67 into 2 into 10 to the power 4 into 10 to the power minus 11. So this will be equal to 1.3 into 10 to the power minus 6 Newton. So this will be the value of force of gravitation between the two balls. So it is very simple, right? We just used the very basic formula or the statement of universal law of gravitation. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.